Hello students, welcome to Educil. In this video, we are going to discuss about a minimum cut, or you can say we are going to prove whether min cut is equivalent to the max flow or not. Before going to start this topic, those who are new, kindly watch the previous video which we had discussed about Ford-Fulkerson algorithm to find max flow. Now let us start. What is cut? Always you should remember we have to disconnect the paths connected from source to destination or source to sink, you can say, is considered as a cut. Okay, minimum cut we are considering here is like the number of edges which we are focusing here, that is a part of it, as well as which we are discussing, like the minimum number of capacities which is there. We can calculate it, how we are going to calculate, how we are going to intake, that is a playing a vital role here. Okay, the min cut is considered as a max flow here. Okay, the number of edges should be minimum which we are fixing up, that we should focus in our mind. That is what the min cut is. Okay, next is you can say another set of rules also being written or to describe it, like set of edges whose removal divides the network into two equal halves, or might be two halves. It's not always equal, sometimes it is non-equal also, we have found out. So here it is of, suppose you can think x and y, there are two different halves. So source will belong to uh, one half, and sink will belong to another half. Here source represent as S, as T represents as sink. The maximum problem arises, like how do we say it's a min cut for us, or how do we find a cut? Okay, there is a problem always. You should remember, I'm just telling you a story. Through this story you will definitely solve any type of problem, but you should keep in mind the story should be like there is a group of terrorists. Okay, so what they are doing to what they are exactly doing, so through might be army, which are our Indian army, so they need to pass through. Okay, let us take the example where how do we avoid, or how, what are the prerequisites to know. I'll tell you with the story. Okay, suppose there is two different nodes as per our algorithm. There are two different nodes, and you just think to find min cut. No doubt there is one edge we are fixing, means we'll keep or not, we have also think of it. Let us think there is a vehicle which a group of terrorists, where in our Indian standard, driver is sitting right hand side of the vehicle, and the road, if I consider, so left hand side of the road as per Indian rule. But here I am fixing the driver side as the right hand side of the vehicle, and here non-driver end will be at the left hand side. Okay, suppose the age is 7, whether we'll consider it or not, we are just discussing with the story. Okay, so there are a group of terrorists through this vehicle, they are moving. Here is the Indian army with a sniper headed from A to B. Okay, sniper, the duty of sniper is, you know, it's very well, the headshot should be there. Okay, so but definitely headshot will be picked. It's not about like we are playing the games, or might be sometimes we are getting the headshot or not. It's not like this. Indian army means, you know it very well. Definitely the if anyone shoots from their end, definitely it will be getting the target. Okay, so non-driver end will be at left hand side of the vehicle, and the right hand side definitely driver will be there. Then how do we correlate with the story? So they need to pass through. Always you should remember the direction from bottom to top. Okay, or you can say towards this direction, always like from bottom to top. Bottom to top, the vehicle should move. This is what the problem is, like we should remember the bottom to top, the vehicle should move, as well as the non-driver end. If the suit to non-driver end, we will not pick the value. Okay, if I'm just writing it, if non-driver end, the arrow is, or I'm just writing, if the arrow towards non-driver end, towards non-driver end, we will pick the value. if arrow is towards driver end, we will not we will not pick the value. So here the simple example I'm also doing, like from B, and the movement should be from top to bottom. Here I'm just giving another example. Here is 7. So whenever there is, or definitely you just think as per the story, driver is running a vehicle. Okay, the problem is like we have to escape. Clear? So if driver end, like any shooter will shoot. Okay, so driver end means definitely the vehicle will stop for a while. When though they are the terrorist, clear, when the vehicle is stopped, so they are ignoring the values and they just ran away by switching the driver to someone, and the non-driver will be shifted to driver. Here non-driver, you just think about non-driver is infinite and driver is one always. This rule will definitely help you in future. So non-drivers, there are many non-drivers are present. Whenever any non-driver will shoot it, there is no problem because driver has to run the vehicle, no other persons. Okay, so driver, if driver end, the arrow will be from driver end, like towards the driver end, definitely the driver will have to shoot it. If it is so, they have to remove or they have not to be picked the values. Okay, here you can check, if the driver end, if the non-driver end, the arrows are coming, means non-driver will be suited. So definitely what they have to do, they will pick the cut value or minimum cut value as 7. Okay, so they will pick it. So they will pick because non-driver end is suited. Here in this case, driver end is getting suited. So definitely what will happen, so though driver is getting suited, so that time they need to switch immediately, though they are switching and they need to pass through. Okay, they need to pass through, they are not worried about the values. In this way, you the mean cut is, for this the min cut is 0. This should be known to you, otherwise you cannot go ahead. Okay, through this we can go further to find the values. Okay, I hope it is clear to you now. In this question, we have already completed. Those who are new, kindly watch the previous videos. There, this question we have completed with the max flow we found is having 19. Okay. Also, we can do not an issue, but still might be if something is getting skipped. So the detailed video is there. Right now, we are just focusing with the flow. I'm just recapping this one. Whenever we are doing it as per the Ford-Fulkerson algorithm, our target should be, we will be focusing on the flow. The initial flow is always 0 for the timing we set. Okay, like we started it, so that's why we set the initial one is 0. Here is 0 initial. Next we have to fix the augmented path. Before that we should have to write augmented path somewhere, and residual capacity, augmented path, a residual capacity. Sometimes you have seen bottleneck capacity, you may write it bottleneck capacity, but as I told you with a proper explanation, bottleneck capacity is always not correct. Okay, because residual capacity might be for initial purpose, we can say it's bottleneck capacity. You can check through the book, it is written clearly. Bottleneck capacity through, if it is initially, we can definitely know it, but for residual, like we have to minus it and we are finding out. So here for this one, I'm just changing the color. This one, this particular augmented path, like augmenting also somewhere it is written, I am writing augmented because this has been already selected, that is why I am saying it is augmented one. Okay, B then T. Once it is done, so the minimum one is 4, that's why we are picking this one as 4 and we updated this. This is what we have done. Okay, so here we have done it. Next path will be this one, which I told you, like the non-conflicting one we should focus on here. Next to this, then this. As per this, we found S, then C, then D, then T. The minimum one is 9. Next we have like here we need to update it, which we should be saying we have found out the residual capacity 0, and we should say we should have to stop there. Okay. Next, uh, we have to change the color. We have to find a way whether we can go further or not. Here the residual capacity we are focusing, that's why I said we're focusing on the residual capacity rather than saying it's our bottleneck capacity. Why? Because we have to check how much capacity left. The From the left with the other capacity we are working, that's why it is residual capacity. How much left means 10 minus 4 is 6. So here is 8, 8 minus 0. Here the capacity left is 6 minus 0 is 6. Here also 6. The minimum is 6. That's why we are taking the residual capacity. That's why I'm writing there as a residual capacity. Then we are updating it. Here we should have to write the path through which we should complete our destination. S to A, then A to D, then D to B, then T. This is for the residual capacity which we found. Here we need to make it circle. Why? Because this is our residual capacity of this path has 0. That's why we said we cannot move throughout. Okay. So this is how we found, and the result which we found is max flow is equivalent to the summation of all the capacity which we found is 19. Here we already found out this one. Now to find the you can say the min cut, we have to follow the rules. I'm just writing it, just changing the color. Here suppose you say it's we can say it's a cut if the source with some certain values, you can say with certain nodes if you can consider, but source and sink should not be equal. You can say can you say this one as a cut or not? No, because if you say it's a cut, you can check this cut will not be valid. Why? Because source and sink is there within it. That's why we are not fixing that one as our uh, a group or might be a cut. Okay, the cut should be like whenever we are cutting the cakes, we should focus on like this should be a equal half or might be unequal half. Whatever the halves that we are discussing, might be there no such conditions we are having. Okay, here the condition should be if you are dividing it, so source will be in a different side, sink will be in a different side. Clear? This is what we should be targeting here. Like the cuts could be, many cuts could be possible, not an issue, but how do we find the values? That is the main working architecture, or you can say approach here. You can say this is considered as a chord, no doubt it's a chord also, so I'm representing that one as C1. Clear? Another chord could be possible here, which is C2. Like we are equally dividing. Whenever we are considering C1, we should ignore everything. C1, if I cut it, so one side will be S, another side will be A, B, C, then D, then T. This is what for C1. So whenever we are considering, always cut will be focusing on one time. Like cut I am doing, so other will be ignored. Like C2, C3, whenever you are focusing on any cuts, here you just think this is our C3. You can consider this as R also C4. So you should run the vehicle, then you get the answer, proper answer. Okay. Whenever you are running the vehicle, suppose here is non-driver end and here is driver end, the vehicle should be from bottom to top. So the vehicle, I'm just changing the color. Here when the vehicle is coming, here non-driver end and here is driver end. Non-driver end, the values are coming. So we can pick this value. Which value? The capacity. Okay, here we found out the result. I think we should have to remove it for a while to find the the proper should be there, might be it's overlapping with the different colors. I need to remove it, and we should focus on the only the chords we should focus. Okay, only chords we should focus, through which it could be very much easy for us to understand. That's why I remove everything. Okay, now you can go for the dots also, or you can say a chord could be written in this way. C1, whenever we are focusing on C1, S will be in a side, other side, this will be another side. When we focus on the C2, for C2, definitely the other half will be A, B, D, T, and another side is SC. Clear? So here, if I consider this C3, this could be having A, C, S another side, B, D, T is another side. Okay, this could be done. So here another you can do C4, but you cannot say it's C5 because source and sink in a same group. That's why we shouldn't say it's a cut. Okay, cut will be, we will be disconnecting the source with a sink. Clear? Next, we are running the vehicles. Here the vehicle which we have, you should remember the driver should be right hand side of the vehicle, non-driver will be left hand side of the vehicle, and the movement should be bottom to top. Whenever we are running, the vehicle is starts its movement. Here the vehicle, here is D, here is ND. The shooter will shoot towards non-driver end. I said if non-driver end will be shooted, we will pick. Why? Because the smooth movement of vehicle is there. No need to worry about. If driver will get shooted, that time we will be having a problem. Okay. So here what we have to do, we have to pick for C1. I'm just writing it here. For C1, first we will pick 10. Next, whether we'll pick or not, we have to check it. Now the vehicle is at this side, driver and non-driver. The shooter will shoot again the ND. That's why a non-driver end you can say. Then we will pick the values. The values will be the capacity we are picking. So it is 20. C2. Then for C2 we have to check. So here the vehicle is at non-driver end and this is driver end. So the movement of the shooter will be this side, like here the based on the arrow mark we are saying. Okay, so arrow mark from C to D, here the arrow mark from S to C, that's why. Clear? So non-driver end is getting suited, so that's why we can say the capacity will be picked, not an issue. Next, here the driver end is this side and non-driver end is this side. Here the movement of the, the shooter will shoot to the driver end. If driver is getting shooted, so we should have to pick 0, means we are not picking the values. Okay, so here in this case the driver end and non-driver end, so non-driver end is getting shooted, that's why we are picking the value as 10, the total value is 19. For C3, here the non-driver end is this side, driver end is this side. So non-driver is getting suited, so that's why we're picking. Here also uh, the non-driver is suited, so that's why we say it's 8. Here the non-driver is end is suited because from A to B there is an arrow. Through this we can say 4 is getting added. Like for C4, here you can say non-driver end and here is driver end because D to T is there, so here we are picking 10. This is non-driver and this is driver end. B to T, that's why we're picking 10. Here is 21, here is 20. Clear? what we found, the chords, from the chords how we are finding the values here. As for these three or four chords which we found, the answers we found as 19 here. So in this case which we found is max flow we have done by considering these three, you can say three arrows are there, but we have selected only two. Based on selecting two, which is minimum for us, out of these cuts the minimum is like the minimum values which we found is this one. That's why we said the min cut. All are called as cuts for us. This is a minimum cut or min cut. So here our main cut, which is the minimum for all the cuts, is equivalent to the max flow. This is how we proved that. So mean cut is equal to max flow. We found. Okay, because of this reason. Better I should write it here. The max flow value which you got is this one. All the cut, the value of cut should be minimum. If the value of the cut is minimum, definitely that is a max flow. This is what our target is. We found it, and I kept a second question for you also. You can say, I'm just changing the color. This is one cut. You can say cut will be represented this way also. This is another cut C2. This is another cut C3. Only just three example we will be taking care of. Here the vehicle will start its movement. Here is driver end, here is non-driver end. Though again, as for this driver end, non-driver end. So here also the vehicle I'm creating non-driver end, driver end. Here is a vehicle ND, D, non-driver end and driver end, driver end and non-driver end. The vehicle, but the arrow mark is towards. Okay. So this the non-driver end, this is a driver end. So then we should write it well. For C1, the value will be picking or not based on the non-driver end or driver end condition which we have read. So here non-driver end is getting suited, so definitely we will pick the values, no doubt, like the vehicle will move fine. Okay. Here also for this case, for C1 is completed now. C1 is 9. C2, the value which we found is definitely non-driver end, so we will pick the value. Here also non-driver end. Here also we are picking because of non-driver end. That's why the total will be 11. C3, for C3 we will be picking 3 because non-driver end is getting suited. Here also the same thing we are getting. Here is 1. Here the value is 1. Okay. Next the value is 2 because non-driver end is getting suited, so that's why here is 6. So out of this the minimum cut which we found is C3, which is 6. So here you can say max flow, mean cut is 6, which is this one. Okay. You can say the max flow also equal to mean cut, which is 6. Okay. This is what we can write the answer, but we should know how we are picking up the values, or when we are picking up or when we are rejecting, that we should know. Okay. I hope it is clearly understood by you. If any doubt, please comment below. Thank you. Have a good day.